You ever feel like you've forgotten pretty much all the math you ever learned? Well, today we're going to go back to the basics with a real fourth grade math worksheet. And I promise you, we're about to rediscover some surprisingly creative and really powerful problem-solving tools you probably never even knew you had.
So first up, let's look at a simple question. 96 divided by 4. How would you solve it? I mean, right now, in your head. Got an answer? You probably have one way of getting there. But what if I told you there are a bunch of other clever methods, and that old-school long division isn't the only way to go? And that's our first big idea, really. Division isn't just some rigid formula you have to follow. It's more like a puzzle. And like any good puzzle, there are multiple ways to crack it. Knowing these different methods is kind of like having a full toolkit. You can just pick the right tool for the job to solve problems faster and honestly in a way that just makes more sense. Okay, let's start with what's called the distributive method. This is just a brilliant break-it-down strategy. Instead of wrestling with 96, you just split it into friendlier numbers, like 80 and 16. Dividing each of those by 4 is way easier. That gives you 20 and 4. Add them up and boom, you get 24. No long division needed at all. Now here's a math that you might not have learned in school, partial quotients. This is like chipping away at the problem in chunks that you can actually handle. So how many 4s are in 96? Well, you might not know that off the top of your head, but you probably know that 20 4s is 80. Great, subtract that, you've got 16 left over. And 4 4s is 16, so you just add your partial answers, the 20 and the 4, and you get 24. See? It's so intuitive because it lets you work with numbers you're already comfortable with. And this right here, this is the most fundamental way to even think about what division is. Repeated subtraction. Just look at the problem in the top right corner. 35 divided by 5. All that's asking is, how many times can you take 5 away from 35 before you hit 0? And the answer is 7 times. It might not be the fastest method for big numbers, but it's such a powerful reminder of what we're actually doing when we divide. We're just counting groups.
So we've seen how we can break down numbers, but what about shapes? Let's switch gears and move from the world of pure numbers to the physical world of geometry and see how these exact same problem-solving skills apply to the math of space.
Okay, two super important ideas here are perimeter and area. And the absolute easiest way to remember the difference? Just think of your backyard. The perimeter is the fence you have to build around the yard. The area is all the grass you have to mow inside the fence.
So if you wanted to build that fence, you'd need to know the perimeter. You find that just by adding up the length of all the sides. But if you needed to buy grass seed, you'd have to know the area, which you get by multiplying the length by the width. They're two totally different measurements that you find using two totally different operations.
And what's really cool is that these formulas aren't just one-way streets. If you know the total area of a rectangle, but only the length of one side, you can actually work backwards to find the missing side. Since area is just length times width, you can find that missing side by dividing the area by the side you do know. It's like a little puzzle, and division is the key that unlocks it.
All right, let's put our new skills to the test with a classic real-world puzzle. How do you find the area of a shape that isn't just a simple, solid rectangle?
Take a look at this shape. A good way to think about it is like a picture frame. The question is, what's the area of just the frame itself? The shaded part, without the empty space in the middle.
So how do we even tackle this? You can't just multiply two numbers and call it a day. This is going to require a little bit of strategy.
And here's that strategy. It's a really simple three-step process. First, you calculate the area of the entire outer rectangle just as if it were a solid block. Then, you calculate the area of that little empty rectangle inside. And finally, you just subtract the small one from the big one. What's left over, that's your answer.
And this logic, it applies everywhere. It's so useful. The worksheet even uses a more modern example, finding the visible desk space around an iPhone. It's the exact same principle. Just find the area of the desk, subtract the area of the phone, and you're done. So, we figured out how we can break down complex shapes into simpler parts. But what if we could do the exact same thing with numbers themselves? Let's dive into the fundamental building blocks of numbers and uncover the secret code that basically governs them all. The key idea here is understanding what factors are. And it's simple. Factors are just the numbers you can multiply together to get another number. So for the number 12, the factors are 1, 2, 3, 4, 6, and 12. They're kind of like a number's secret building blocks.
So once you get factors, you start to see that all numbers fall into one of two main categories. You have prime numbers. They're kind of the lonely ones. They only have two factors, 1 and themselves. And then you have composite numbers, which are more social. They have more than two factors. This distinction is huge. It's actually the foundation of modern cryptography, the science that keeps all of our digital information secure.
Let's put this to the test. Take a look at the number 43. What do you think? Is it prime or composite? I'll give you a second. It's prime. Its only factors are 1 and 43. Okay, what about 51? This one's a little trickier, but it's actually composite because 3 times 17 is 51.
When you actually map out the prime numbers, like on this chart from 1 to 50, you see something really interesting. They don't follow a simple, obvious pattern. They are this beautiful and mysterious part of how numbers work, and believe it or not, mathematicians are still trying to unlock all their secrets.
All right, for our final section, we get to apply all this logical thinking we've been doing and become number detectives. It's time to crack some secret codes.
The challenge is pretty straightforward. You look at a sequence of numbers and you have to figure out the hidden rule that generates the next number in the pattern.
Okay, check out this fantastic bonus round from the worksheet. The pattern goes 0, 1, 4, 9, 16, 25. So what comes next? And more importantly, what's the rule here? Take a second and see if you can figure it out.
Okay, you ready? The rule is actually beautifully simple. You're just adding the next odd number each time. To get from 0 to 1, you add 1. From 1 to 4, you add 3. From 4 to 9, you add 5, and so on. Now, what's also cool is that these are also known as square numbers, 0 squared, 1 squared, 2 squared, which just perfectly illustrates that there can be multiple, equally elegant ways to describe the same pattern.
And that right there is what's so amazing about math. It's not just about memorizing rules to find the one right answer. It's really about seeing the world in a new way. It's about finding the hidden patterns that are all around us, in everything from license plates to the leaves on a tree. So the next time you see a string of numbers, don't just see a random sequence. See it as a puzzle, a code, a little mystery just waiting to be solved. So, what hidden patterns will you discover?